Hi, let's talk about fractions. I know some of you have been struggling with it, so let's start at the beginning. Alrighty? Fraction has two numbers separated by a line in the middle. Okay? The top number is the numerator. It tells you how many pieces you have. And the bottom number is called the denominator. That tells you what size the pieces are. That's how many pieces you need to make one whole group. Okay? Whole group has four identical pieces, all the same size. Okay, that's how many makes one whole group. This is how many of the pieces you have. Okay, so numerator is how many, the denominator is what size. Okay, got it? And the way to tell the difference is the denominator, the word starts with a D, D down below the line. Down below the line is the denominator. Got that? D down. Okay. So, here are some fractions. All right. So, I think that it's easier to say in the beginning, 1 out of 6. I have one piece out of a group of 6. 1 out of 6 is a mental picture of what you've got. You can say 1/6, but if you're having trouble with that, say 1 out of 6 if you're trying to figure out the size of the group. Okay? Here you have 5 out of 8. Here you have 3 out of 4. Okay? Now you'll notice on the bottom, I wrote improper fraction, meaning that's not right. Can you see why this one, 7/2, because 2, you don't say tooths, you say halves. So 7/2, you can't have 7 because 2 creates 1. 2 of this size piece makes 1. If you have 7 of them, you have way more than 1. That's why it's an improper fraction. Okay? This is going to be more than 1. When we start getting into mixed numbers, you'll see how to change an improper fraction into a mixed number. But if you accidentally switched the numbers, the numerator and the denominator, it's going to look funky like this. So if you make that mistake, make sure you go back and check. Do I have 3 out of 4? Or do I have 4 out of 3? Which is correct? The size of the piece is fourths, and I have 3 of them, then it's 3/4. Okay? Okay. So, you're looking at comparing fractions. Okay? These are unlike fractions, right? To compare them, it's a little trickier. If you have like fractions, that means the size of the piece is the same, that means the denominator is the same. It's easier to compare those because if you're comparing 2 out of 5 and 4 out of 5, 4 out of 5 is a bigger group. We both have the same size pieces. See? Fifths and fifths are the same size piece. But here you have 2 of them, and here, I'm sorry, I'm having trouble with the camera, you have 4 of them. So 4 is greater than 2, so 2/5 is less than 4/5. Okay? It's only if you have the same size piece. If the pieces are the same size, the denominator is the same, then you just compare the numerators. Okay? But if you've got something like this, where you have 2 different size pieces, that's where you use the multiplication to compare pieces that are the same size. So let me just show you something. I have fraction bars here. Okay? This is 3/4. These three yellow cubes is 3/4. All right? Go like that. Okay. 3/4. This is 4/8. Can you see the difference? The eighths are smaller pieces. This is upside down. How's that? Better? Okay. 3/4 are bigger pieces because you only need 4 to make one whole. The eighths, on the other hand, are smaller because you're taking that one whole piece and breaking it into 8 parts. So even though you see a big number 8 there, that doesn't mean they're bigger pieces or it's a bigger fraction. You have to try to make them the same size. So the way to make these the same size would be to multiply, right? So you can multiply okay? It's a big glare here. All right, that's better. 3/4 times 2. 4 times 2 is 8. Okay? So you have to multiply the numerator by 2 to get the correct number of eighths. So 3 times 2 is 6. So 3/4 is equivalent to 6/8. So if you replace that over here, okay? Sorry, I'm getting sloppy. 6/8 compared to 4/8, okay, it's the same size piece now, eighths and eighths, same size pieces, so now you just have to compare the numerator, the how many part. Here you have 6, here you have 4. 6 is greater than 4, so 6/8 is greater than 4/8. That's why you have to find equivalent fractions sometimes. Okay, that's the why about that question. Okay. Okay, sometimes you can't multiply one of the denominators to make the same size pieces because you don't have a number you can multiply by to get there. So if I have 1/3 and 2/5, right? I can't multiply 3 times a number to get 5 because 3 times 2 is 6. That's already too many. So I can't multiply 3 by a number to get 5. So what I have to do is try to figure out, how can I make them both the same size pieces? That means I'm going to have to find an equivalent. Equivalent means equal, right? I have to find an equivalent fraction for both of them that have the same denominator. So you might notice that if I multiply this number by this number, I can find an equivalent fraction. So 5 times 3 is 15, right? So if I change them both into 15ths, okay, this looks a little confusing, but I'm just trying to show you what I'm thinking. Alrighty, so how do I get from 5 to 15? I multiply by what? Right, 3. So you're going to multiply the numerator by 3 also, right? Like that. So 1 times 3 is 3. Okay. Now on the other side, how do I get from 5 to 15? Wait a minute, I lied. 3 times 5 is 15. 1 times 5 is 5. Okay. Okay, good. It's not like looking in the mirror. This is really difficult for me. So, over here, 5 times 3 is 15. 3 times 5 is 15 on this side. Okay, so I'm going to multiply this side by 3. 5 times 3 is 15. And 2 times 3 is... Okay. 6. So let's put a 6 there. Okay, let me look at this again, make sure I got it right. So, I changed my thirds into 15ths. I changed my fifths into 15ths. So now I can compare those two equivalent fractions. I found an equivalent fraction for 2/5, made it 15ths. I found an equivalent fraction for 5/15, for 1/3, and made it 5/15ths. Now I can compare the 15ths. Sorry about the glare. Okay. So I'm comparing 5/15ths and 6/15ths. 6 out of 15. Okay, they're the same size pieces, so 6 out of 15 is going to be bigger. So we show it that way. Okay? Does that make sense? Unless you've got fraction bars and you can put them right next to each other, you have to know how to convert fractions, find equivalent fractions, and compare fractions that way. Okay? Okay. Okay. So we talked about improper fractions. Improper fractions, as we said earlier, was when you have a numerator that's larger than the denominator. Okay? That doesn't make sense because that's going to be more than 1. So, what do? Let's take that 7/2. Okay? 7/2. How many halves do you need to make 1? What was that? Yes, you need 2 halves to make 1. So, if I subtract out 2 halves, okay, that's equal to 1. Okay? I'm going to take that one out. And how many do I have left? I have 5 halves left. Right? So I take out another 2 halves. That's another 1. Equals 3 halves, right? Take a look. 7 halves. I took out 1. I have 5 halves left. I took out another 1. 2 out of 2 is 1. 1 whole. 2 halves is 1 whole. Now I still have 3 halves. Wow. So if I take out another 1, I need another board, I guess. There. Okay. I'm going to have to take out another 2 halves. That's another 1. And I've got 1/2 left. Right? So, looking on the bottom, I had 1, 2, 3 holes, right? I took out 2 halves, made it a 1. Took out another 2 halves, made it a 1. Took out another 2 halves, made it a 1. And I still have 1/2 here, but I can't use that one to make it a whole. I have that left over. So I have 1, 2, 3 plus that 1/2. So this original improper fraction is equal to 1, 2, 3, 3 and 1/2. Okay? That's a way to think of it. 3 and 1/2. Sorry, it's a mess. Okay, so this has been a little experiment to see if I can teach online by video. Maybe it'll help you remember the difference between a numerator and a denominator, right? D, denominator, down, that's the number on the bottom. That's the size of the pieces. And the numerator is on the top. That's how many you have. Okay? And that you can multiply both the numerator and denominator by the same number to get an equivalent. Equivalent means equal size piece. So if I have 2/4 and 4/8, they're both equivalent to 1/2. See? Okay, so 1 out of 2 is the same size as 2 out of 4, is the same size as 4 out of 8. So, how many sixths would you need to be equivalent to all three of these fractions? That's right, 3. You need 3/6 to be equivalent to 1/2, 4/8, and 3/6. Okay? That's what equivalent fractions means. So when you're comparing fractions, you can use what you've learned about finding equivalent fractions using multiplication to multiply the numerator and denominator, okay, by the same number, top and bottom, so that you can change the number of pieces and the size of the piece, and you find equivalent fractions. That's what equivalent means. These have, different names, okay? The individual pieces are different sizes, but they're the overall size of the group, whether it's 1 out of 2, 2 out of 4, 3 out of 6, or 4 out of 8, okay? The size of the group is the same. Okay. All right, I'm going to stop right there. I think I've confused you enough. I hope I've helped somebody, please.